So I just want to discuss this graph with you. Okay, you know, when we have studied energy diagram, in chapter nuclei or atoms, we have discussed energy band. Understood? In which we have discussed that different electrons are are present in different energy bands. But reason is that in that case we have discussed for an isolated atom. Got it? You have seen that energy band diagram coming like straight lines, very fine straight lines like this. Can you see that? This one. Okay, very fine lines of energy. Okay, energy band we get only when atoms are isolated one. But in real life situation, in real life situation it is very much difficult for atom to be isolated. You know why? Because any material is made up of trillions and like many atoms to get join together to make any material. Got it? So in that case, we can see that atoms are not isolated with each other. They are combined, very closely packed. And due to that reason, electrons are electrons are interacting with each other and they are distorting, this word you can use, that they distort, energy band. Got it? So you can see that these these energy band representing, those orbits which are very close to nucleus. Got it? As I have told you that there are two kinds of electrons. See, when you understood electron, what is bound, what are bound electrons, what are free electrons, so it will be easier for you to understand this chapter. Okay, and this graph too. And not only this graph, later on we will discuss energy band gap and all things. So please, I request you to just try to concentrate. Okay, and if you are having any problem, I will come to that chat box. You can write questions and you can ask. See, these electrons, these electrons are bound electrons inside atoms. These electrons. So you can see that they don't interact much. Got it? They don't interact much with other electrons, But here, these electrons are not bound. They are outermost cell, in outermost cell of the atoms. Okay? So when two atoms interact with each other, these outermost electron interact with other electrons of other atoms. Got it? In that way, some electrons can reduce their potential energy, some can increase their potential energy, like that. In that way, the energy diagram is not like fine line. They distort that energy and make this kind of structure, in which some band, here it is not only a single electron. We are talking about millions and trillions of electrons. Okay, so that's why it is not a single line. This consists of very fine lines. Remember, got it? These consist of billions and trillions of electrons. That's why we are not representing for a single electron or for a single atom. That's why we say that it is a band. It is what? It is a band. Okay? This energy is not representing energy of any one electron. Okay? This is not representing energy of any one electron. These are representing energy of millions and trillions of electron, making a band kind structure. Got it? I hope you are getting it. I am telling you again, please try to understand. These electrons belong to innermost orbit. These electrons, simply, listen, I'm not going to that scientific notation. I'm just trying to tell you in layman language. These electrons is innermost orbit. So when this atom will interact with the other one, these electrons will not interact with other electrons. So you can see that their energy is like fine line, discrete one, okay, specified one. But these electrons belongs to outer orbits. Got it? So they have to interact with other electrons of other atoms. So in that way, they are creating a band, they are creating a band. One is called lower energy is called balance band. This is, you can see that this is our energy one. Y-axis we are taking energy. So this one is having lower energy. This is having lower energy. This is termed as balance band. Okay, and this band is having little bit higher energy. Got it? So one question in MCQ they can ask you that which band is having lower energy, conduction band or balance band. So what you have to answer? If they are asking about higher energy, then you have to answer conduction band is having higher energy and balance band is having lower energy. And this gap, you can see that this gap is called, my dear students, this gap is called energy gap or forbidden gap. Got it? This this gap is called energy gap or forbidden gap. Got it? So this graph is exactly we have drawn from that observations and experiments. Okay, but we can simplify this graph. Got it? How we can simplify? I just want to tell you. Okay, these are the explanation of this one that I have given you simply. You can see that one more thing I want to tell you, that you can see that this is what, this is interatomic spacing. Can you see this one? You have to also go through this one more, like, thing is that this is called interatomic spacing that we have used in x-axis, on x-axis. Okay, so you can see that when interatomic spacing is more, again, interatomic spacing is more, is means what? Like atoms are not very closely packed, atoms are far away from each other. So when atoms are far away from each other, then again electrons don't have to interact that much. Got it? I hope you are getting it. Understood? See, two things will work here. Got it? One is innermost orbit have nothing to do with the other atoms because they don't interact. When some guest is coming to your house, whether you will interact, your father or mother will interact, or your 1 year young brother or sister will interact, tell me. Okay, obviously they are very much bound. Okay, they are not that much free, so they won't interact with your guest, either your mother, your father, any elderly person, or maybe you can interact with your guests. Are you getting my point? Same thing is happening in the atom as well. Got it? When atoms are like connected to each other, so outermost electrons will be interacting with other electrons, not innermost. So you can see that their energy levels are defined, well defined energy levels. Are you getting my point? And for outermost also, when atoms are at very far away distance, they don't have to interact with each other, then you can see that when interatomic spacing is more, there again their energy is well defined, not distorted. But as they are coming closer, to each other, they distort their energy levels. That's why creating this kind of figure. Okay, I'm coming to my chat box and tell me, have you understood this concept? Yes or no? Please tell me. If yes, give me a thumbs up. If no, you can ask me questions. Do it fast so that we will move to next topic. Please do it fast. Hello, are you getting my point? Hello? Hello, are you getting my point? Thank you so much. Okay, okay. Thank you so much. So please, you can ask me, either you can ask me question, or please tell me by either switching on your microphone or giving me a thumbs up. Thank you so much. Okay, 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 okay. Okay. Thank you so much. So this is our that diagram from which we will now define our energy band diagram of solids that will be coming now. You can see that. Okay, this, base of, because sometimes you may feel that why we are drawing this kind of diagram. Okay, so if that atom is atom of conductor, if that atom is atom of a conductor, so their distortion will be like this. Their distortion will be like this. in which valence band will overlap conduction band, you know. Now CBSE will, if they will ask, they will ask you this diagram, not that, but still, if you are able to understand that diagram, it will be much better. Got it? Because that diagram is the basis of this one. That diagram is the basis of this diagram. That means how and why we have drawn diagram like this. Got it? So please try to understand. In conductors, valence band is overlapped by conduction band, and there is no energy gap. Remember, there is no energy gap, zero energy gap. Okay, you can also just imagine one thing, you know, there is a very, like there is a water body which is very not that much broader. You can jump that one easily. Okay, you are having a limitation how much distance you can jump at once. Okay, how much distance you can jump at once. Understood? So if it is very narrower, okay, you can jump it easily. Understood? And suppose if there is no any gap, you can easily walk. In the same way, you can see that if I am an electron, I can walk very easily. No need to jump and go from valence band to conduction band. Please try to understand. Electricity only means this one. If electron is easily moving, okay, it will conduct electricity. Got it? So when electron can easily going from valence band, to conduction band, you know, in this case, no need to jump. It can only just going very easily. Got it? But when you talk about insulator, please try to understand. When you talk about insulators, so this is valence band. We have already discussed that valence band is having lower energy. Electrons which are present in valence band. Now you can ask me questions, sir, what is valence band and what is conduction band? Got it? So valence band are those in which electrons are bound to the nucleus. You can consider these as orbits, you know, orbits around nucleus. So those orbits in which electrons are very much bound to the nucleus will be called valence band. And you know that in orbits which are closer to the nucleus, they are having very less energy. Am I right? So if I want to ask you one question, that what is the energy of electron in the first orbit, please tell me. JNV Vaksa, you want to ask any question? You can, no problem. Students, I want to ask you one question. Anyone, please. Can you tell me what is the energy of electron in our first orbit? What is the energy of electron in our first orbit? Can you please tell me? What is the energy of electron in first orbit? Very nice. Very nice. So, as you have written that minus 13.6 electron volt, as we go away from the first orbit, yes, thank you so much, Janvi Jorhat and class 11th batch. Okay, about impact parameter, Janvi Vaksa, after this class, I will connect you. Please don't leave after this class. We will discuss about impact parameter, okay? Because this topic is not belongs to today's topic. So, but don't worry, we will discuss it, okay? After the class. I request you not to leave class, okay? I will be there after 9:30. Just for 10 minutes we will discuss, okay? Thank you so much. No, I'm asking, see, I just want to make sure that are you, my dear students, I just want to make sure that you should understand that concept that if electrons are near to the nucleus, they are having less energy. You know why your younger sister and brothers, when they are infant, like 6 months, 1 year, 2 year old, you have seen that they are mostly attached with the mother, your mother and your father maybe. Do you know why? Other than, there are different things, but one more thing is that they have very less energy, you know. They have very less energy and they cannot do their things by their own. Understood? So you can understand electron in this way too. Got it? But as they grow older, okay, somehow they are moving farther away from the parents. Am I right? In the same way, electrons also, when they are close to the nucleus, they are having very less energy. Minimum energy that they can have is minus 13.6 electron volt. But as you move further away from the nucleus, that means excited states, those are called first excited state, second excited state. Okay. Yes, JNV Jorhat, we have already discussed it, okay, about this. Again, please be in the class. Don't leave. After 9:30, we will discuss, okay? The question that you are asking, we have already discussed, but don't worry. We will again discuss, okay? Please don't leave. After 9:30, we will discuss it, okay? So this is now you can you know that balance band means what? Those electrons which are very near to the nucleus, you can term it as they are balance band. They are forming what? Balance band. Again, why we are saying it is a band? Because we are not talking about a single electron. Got it? If we are talking about a single electron, we can just write down the exact amount of energy. Am I right? Are you getting my point? Why we are saying this is a band? Because in band, in your class, in your school also there is a band, and band cannot be formed by a single person. you know Band should be having a large number of person, yes or no? Many person will be there to form a band, and then they will use their drums and all, forming a band. In the same way, this is not talking we are not talking about a single electron, we are talking about millions and trillions of electrons. That's why they lie between these energy levels, forming a band. So these electrons will be termed as valence band electrons, and this is called conduction band, in which electron have to gain higher energy, and they can jump from here to here. You can see that if you are having a condition that water body that you have to cross, if that is broader, and even if you will jump, you will try to jump, you might not able to reach here. Okay, you can only reach here. In that way, you are not able to cross it. So if electrons also are not able to cross this energy gap, so that's why it is called insulator. Why? Because it is almost impossible for electrons to move from here to here. It is almost impossible for electrons to move from here to here. Why? Because energy gap is very much high. It is more than 3 electron volts. Please try to understand. Okay, 3 electron volt. Got it? So in insulator, you can simply write that energy band gap is very much high. Energy band gap is very much high, my dear students. That's why electron is not able to jump from valence band to conduction band. Got it? Now there comes a third type of material that is called semiconductor. There comes third type of material that is called what? Semiconductor. Okay, so in semiconductor, energy band gap is not overlapping, as well as is not that much high. Okay, it is in between the solids and in between the conductors and insulator. It is less than 3 electron volt, but more than 0. Got it? It is less than 3 electron volt, but more than 0. So if we give some of the energy to the electrons, it can jump from here to here. Got it? It can jump from here to here very easily after getting energy. So this kind of material is termed as semiconductor. Okay, so as we have already discussed that we have two kind of intrinsic semiconductor, naturally occurring semiconductor without any impurity. There are many words that can be used for intrinsic semiconductors. Intrinsic are those which are naturally occurring without any impurity. Got it? Okay. So we have already discussed about semiconductor. Okay, and you know that for silicon that energy gap is how much? For silicon that energy gap is 1.1 electron volt. Got it? And for germanium it is less than 1. It is 0.72 electron volt. I am talking about that energy gap. Got it? So here you can see that we have discussed that energy gap should be less than 3 electron volt. Yes or no? So for semiconductor silicon, it is what? It is 1.1 electron volt. And if it is germanium, what it is? 0.72. I hope you are getting it. Okay. So this is called energy gap. Okay. One more thing they can ask you that at 0 Kelvin temperature, at 0 Kelvin temperature, semiconductor behaves as insulator. And I hope that you know about 0 Kelvin temperature. Okay. So at 0 Kelvin temperature, it is a temperature after which we cannot obtain less temperature than that. Okay. So that is called 0 Kelvin temperature, least temperature that we can achieve. At that temperature, a semiconductor will behave as an insulator. You know why? Because at that temperature, electrons are not having that much energy to jump from valence band to conduction band. Okay. Those Gen V which have joined just right now, we have already discussed about valence band and conduction band. If you want to know more about that, you can don't leave the class after 9:30. We can discuss about that. Okay. Now, intrinsic semiconductor. We have already discussed intrinsic means what? Again, many times they have asked about intrinsic semiconductor and extrinsic semiconductor. Got it in previous years. So intrinsic semiconductors are pure semiconductor without doping, without added impurity. Examples are silicon and germanium. Got it? Examples are what? Silicon and germanium. But problem with these kind of semiconductor is that in these kind of semiconductors, number of electrons is equal to number of holes, because they are forming naturally. They are forming what? Naturally. So number of minority charge carriers, you can say that number of electrons is equal to what? Number of holes. About minority charge carriers, we will discuss later when we will discuss extrinsic semiconductor. So, have you understood about this concept? What is intrinsic semiconductor? Again, I'm telling you because this question asked in exam many times. Intrinsic semiconductors are naturally occurring pure semiconductors without any added impurity. Got it? Examples are silicon and germanium. Okay. When you see this energy band, so by seeing energy band gap also, we can say that this belong to what? Germanium, because energy band gap is how much? 0.72 electron volt. And if you want to draw from for what? For silicon, it should be what? 1.1 electron volt. Okay. And if it is, suppose if you take for any insulator, if you take for any insulator, the energy band gap should be more than 3 electron volt. Remember, energy band gap should be more than how much? 3 electron volt. Okay. So these are the problems related to intrinsic semiconductor. Also, you can say that these are the properties of what? Intrinsic semiconductor. Okay. In intrinsic semiconductor, these are the energy band gap. Okay. For different semiconductors, this is the number of electrons here is equal to what? Number of holes. Number of electrons is equal to what? Number of holes. Got it? And also the conductivity of intrinsic semiconductor is very low. Why? Because again, when we talk about intrinsic semiconductor, free electrons or free charge will be very less. Remember, free charge is very less in case of intrinsic semiconductor. And to conduct electricity, my dear students, we need free charges. Okay. So because free charges are very less in intrinsic type semiconductor, so they will be having less conductivity. And if they are having less conductivity, they will have high resistivity, because resistivity and conductivity are inversely proportional to each other. So if they are having less conductivity, they are having more resistivity, and due to more resistivity, they are not able to conduct electricity properly. Okay. So to make intrinsic semiconductor more useful, to make intrinsic semiconductor more useful, we dope it. Got it? One more example that you can imagine about yourself is that suppose a child took birth. Got it? And we just close that child inside a room. I hope you will get this thing that I want to share with you. By this you can remember, you can learn this concept very easily. Understood? Like a child took birth and you kept that child inside a room for 20 years. You are giving food and everything, but you are not giving them training. He is not going to school, nothing. Okay, so his mind will be pure, but will it be useful for our society? Obviously no. Because whatever things we need in our society like education and manners, tactics, he or she will not have that one, even though his or her mind will be intrinsic one. Okay? But that is not that much useful for our society. Are you getting my point? Even though his or her mind will be intrinsic without any impurity, doping. Impurity is not meaning that it is negative thing. Impurity is not always a negative thing. We also make gold impure. 24 karat gold is pure one, but we mix something in that to make it more stronger. Are you getting my point? So impurity does not mean negative thing always. Got it? है ना? And doping is also not always negative. Doping is always negative when we talk about sports, Olympics and all. Got it? But in case of semiconductors, when we discuss about semiconductor devices, doping is very much important. So again, one more question they can ask you. I hope you have understood that why intrinsic semiconductor is not that much useful. Got it? Because it is having less conductivity, number of holes is equal to number of electrons. Got it? They are having a little bit more energy band gap. Can I ask you, have you understood about intrinsic and extrinsic semiconductor? Please tell me. Are you getting my point? Yes or no? If yes, you can give me a thumbs up or you can ask me a question. Thank you so much. Okay. JNV South Tripura, your question is, sir, why a silicon is a conductor, is a semiconductor? JNV South Tripura, my dear students, silicon is not a conductor, it is a semiconductor, and carbon is an insulator, while silicon, SN means what, sir? You are talking about tin or something else? Hello, JNV South Tripura. Tin, yes. Okay, so I will discuss tin about later, but carbon is still a semiconductor. Students, carbon is a semiconductor, not an insulator. For example, you can see that graphite, the pencil that you are using, graphite, you have used, we use that in pencils, and that can conduct electricity. Okay, not that much high conductivity is there, but still pencil can conduct electricity. And carbon is having many forms. Again, carbon is having many forms, and conductivity also depend upon the crystal structure. Not only, yes, conductivity sometimes also depend upon the structure, of crystals. So carbon is having little bit different one. That's why some form of carbon can conduct electricity and some form cannot. Okay. But when you talk about bond between the carbon atoms and silicon and germanium atoms, they are same. They are covalent bond. Okay, sir? And I hope that you will elaborate it to students. Okay. Okay. And if still you are having problem, we can discuss after 9:30. Okay, sir. About tin, I want to discuss about tin. Okay. So be with me after 9:30, sir. Huh? Thank you so much. So those Gen V which want to discuss anything from this chapter, they can still be with me. Okay. Here I just want to, those topics which are important and coming, at least students should know about that. And I know that we all are trying our best, okay, to make a student understand about semiconductors and all the topics. Okay. So my dear students, let's talk about doping now. So now we know that why intrinsic semiconductor is not that much useful. Okay, to be in pure form is always not useful for society, useful for us. As I have given you the given you example that if gold will be 24 carat, it will not be that much useful for us. So we make something, we make it impure by adding something, and we make it 22 carat so that it can be more useful. We can make it, jewelry from the gold. Got it? In the same way, we also have to make intrinsic semiconductor extrinsic to make it more useful. So if they will ask you a question that why to make intrinsic semiconductor extrinsic, so you can simply write down to make intrinsic semiconductor more useful, we have to dope it with deliberate impurity. Okay, deliberate word should be used there. Okay, so here you can see that doping is a process of addition of a desirable or deliberate impurity atoms to a pure semiconductor to modify its property in a controlled manner. In what? Controlled manner, So that impurity should be controlled. The impurity atom added are called dopants. We will discuss later in this class that which kind of dopants we are going to use to make extrinsic semiconductor, also having two types. Extrinsic semiconductors are also having two types. So I just want to know from you, my dear students, that can you tell me which are two types of extrinsic semiconductor? Can you please tell me? We will just discuss that. Hello? Okay, no problem. Okay. So doping means what? Doping means to add desirable impurity in intrinsic kind of semiconductor like silicon and germanium. There are methods of doping. Methods of doping are, when semiconductor are melted and then you can add those impurities inside that atom. Actually, it is a kind of engineering thing. Okay, we are having many kind of devices using which we can add dopants to the intrinsic kind of semiconductor. This is one of the method that first you have to melt the intrinsic semiconductor and then you can add desirable impurity. Okay, and that impurity is not that much high amount. Okay, it is around parts per million, 1 parts per million. Okay, then another method is what? Dopant atom should be given very high speed. Okay, bombarding means what? Bombarding means just you have to give a very high energy to the dopants so that dopants can stick, or they can connected with their ions, intrinsic semiconductor. Okay, for that what we have to do is we have to provide dopants a very high energy. Got it? But industry, if we talk about industrial way, like we are having semiconductors, diodes in our daily life use. We are having semiconductor diodes in our daily life use. uh, just I want to show you. Wait. I hope that this is visible to you. Have you seen this kind of? Have you seen this kind of here? Anode and cathode is written there. This kind of device inside a laptop, and computer. I hope you have seen this kind of diode. Okay, this is called semiconductor diode, p-n junction diode. Okay, this one, this is the symbol, then it is the original kind of diode, and this is the representation of it. Okay, so coming back to the PDF. Okay, so what I want to tell you that in industry, when we are like making p-n junction diodes, okay, semiconductor diodes, so we use this method and this method. Okay, because this is more economical and needs very less effort. Okay, it can be done very easily. So there are three methods of doping. Okay, although they have not asked this one many times, but still we should know about that. So these are the methods how we can dope a pure semiconductor and make it impure. So intrinsic means pure semiconductor and extrinsic means impure semiconductor, but that impurity, my dear students, that impurity should be controlled. That impurity should be controlled and that should be desirable. Now, extrinsic semiconductors are of two types. Extrinsic semiconductors are how many types? Are of two types. One is N-type, one is N-type, and other one is P-type. Got it? One is N-type and other is what? P-type. Can I ask you one question? Why this is so? Why one is called, very good, thank you JNB Golpara, thank you so much. Why one is called P-type and why other is called N-type? Please, any JNB, can you please tell me, students? You just tell your teacher and please, any one of you, please write my dears. Why it is called P-type and why it is called N-type? Is there any reason or just we have named it? Can you hear me? Why it is called N-type, why it is called P-type? Okay, no problem, we are discussing it. One is negative charge carrier and another is positive charge carrier. Very good, very good. One is having large number of positive charge, that is holes, and another is large number of negative charge carriers, majority charge. You can simply say that in one kind of semiconductor, majority charge carriers will be holes, that is positive, and in one kind of semiconductor, negative charge electrons are the majority charge carriers. That's why it is called negative charge. So we can say that it is on the basis of their charge carriers. We have named these two semiconductor on the basis of their charge carriers. Got it? So first we will discuss about how to make N-type semiconductor. How to make N-type semiconductor. So when a pure semiconductor or silicon or germanium doped with pentavalent, okay? So please try to understand this concept. When we talk about pentavalent, so pentavalency, you can write it as what? Pentavalency. Pentavalency means what? Those atoms in which, please you can write down what is meaning of pentavalent. Pentavalent means those atoms in which in their outermost orbit or cells there are 5 electrons. How many electrons? 5 electrons. I hope you are getting it. Okay, in their outermost cells there are how many electrons? 5 electrons. Got it? There are 5 electrons. So that's why they are called pentavalent. Penta means what? Penta means 5. Got it? Examples are phosphorus, arsenic, antimony, bismuth. Got it? Phosphorus, arsenic, antimony, and bismuth. Okay? So these all are having, I think from group 14. Okay? So phosphorus, arsenic, antimony, and bismuth, these all are having 5 electrons in their outermost shell. That's why they are called pentavalents. Okay, and now how they will be added and why they are forming electron as majority charge carriers, we will discuss about that. Okay, we also know that, in silicon and germanium, they are connected with each other. Atoms are connected with each other using which bond? So answer will be what? Covalent bond. Okay, when you talk about intrinsic semiconductor like silicon and germanium, atoms are interconnected with each other using which kind of bond? Covalent bond. Okay, and co means what? Co is coming from cooperation. So atom cooperate with each other, they will share one electron with each other. Got it? So when bonds are made by sharing electrons with one another atom, got it? So bond that will be created is called, the bond that will be created is called covalent bond. So just try to remember that in case of silicon and germanium and many semiconductors, bond created will be what? Which kind of bond in intrinsic type of semiconductor? It will be covalent bond. Got it? In which electrons are shared among the atoms. Okay? Yes. So when we will go to the diagram, you can see that this one. Now try to see. This is your silicon, but after doping, you can see that after doping, your silicon atom is removed, isn't it? After doping, your silicon atom is removed. Your silicon atom is removed, and instead of that silicon atom, arsenic is put here. Yes or no? We have put arsenic instead of what? Silicon. But because arsenic is a pentavalent, okay, it is having 5 electrons in the outermost shell. So what will happen? You can see that this electron belongs to this one and this electron belongs to this one. Okay, so 1 electron for arsenic, 2 electron for arsenic, second electron for arsenic, third electron for arsenic, working with one another, and the fourth electron for arsenic. They all are working. Yes or no? They got their job. Why? Because when we talk about, we have discussed it already, that we need how many electrons to make covalent bond? When we talk about silicon and germanium, dear students, we need only 4 electrons. Okay, so when we have removed silicon and put arsenic here, हमने क्या किया? फिर जब हमने सिलिकॉन को रिमूव कर दिया, आर्सेनिक को डाल दिया हमने यहाँ पर, तो हमने क्या किया? हमने 4 इलेक्ट्रॉन हमें चाहिए था, पर साथ में कितना इलेक्ट्रॉन आ गया? 5. 4 इलेक्ट्रॉन चाहिए था. We needed only 4 electrons, but when arsenic was there, arsenic is having 5 electrons. So 1 electron will not get any job. Yes or no? This electron is not getting any job. Yes or no? So if this electron is not getting any job, so this electron will be free. Yes or no? Tell me. This electron will be what? Free. So because this electron is not doing any job, it is not working to make. It is obviously a work. Yes or no? Like we also work. You also have to work when you grow up. Okay, after college or maybe after BTech or MBBS. Okay, so you have to do some work. So there are work for only for 4 electrons. So 4 electrons are working. 1 is not working. 1 remains left. So those remains left is called free. So this electron will work as free electrons, and this electron will help in conduction of electricity. This electron will work in conduction of what? Electricity. Got it? So are you getting my point of free electron? If yes, give me a thumbs up, or you can ask me a question. Do it fast. Yes. Are you getting my point? What is meaning of free electrons in semiconductor? And why N-type semiconductor will having free electrons? Are you getting my point? Okay, I hope you are getting my point. Okay, so now come to the next point. That's how a negative type semiconductor, a negative type semiconductor will have more number of free electrons. I hope you are getting it, okay? Because here we are talking about only one atom, but there is not only one atom, there are many impurity atoms that we have added to the silicon. So there are very large number of what? There are very large number of what? Free electrons. So due to this, we can see that there is a change in that band diagram. There is a change in that band diagram. You can see that earlier it was how much? Earlier it was 1.1 electron volt for what? Earlier it was 1.1 electron volt for what? Silicon. But now it is reduced to how much? But now it is reduced to only 0.045 electron volt. Now it is reduced to only how much? 0.045 electron volts. So in that way, now electrons can easily jump from valence band to conduction band. Electron can easily jump from where to where? Valence band to what? Conduction band. Okay. So in this way, an n-type semiconductor is having a large number of electrons, and because it is in large number, that is why it is called majority charge carrier. That's why it is called what, my dear students? That is why it is called majority charge carriers. Okay. So in n-type semiconductor, they can ask you a question that which is the majority charge carrier in n-type semiconductor. So what you have to answer? In n-type semiconductor, majority charge carriers are electrons and minority charge carriers are holes. Got it? Majority charge carriers are electrons and minority charge carriers are holes. And what is the benefit of doping? You can see that energy band gap reduced. Energy band gap is reduced from where to where? It is reduced from 1.1 electron volt to 0.045 electron volt. Okay. So now we will discuss about p-type semiconductor. P-type semiconductors are those semiconductors, again, which are doped with not pentavalent. This time it is not pentavalent. This time it is what? Trivalent. Remember, this time it is what? Trivalent atoms, in which in their outermost shell 3 electrons are there. How many electrons are there? 3 electrons are there. Got it? So, and examples of those trivalent atoms are, please write down, because sometimes they can ask you, because I have seen that many times in question number 29 and question number 30, most of time they have asked question from semiconductor devices, question number 29 and question number 30. So in that MCQ, they can ask you which among the following is a trivalent impurity atom. Okay, so you have to answer that accordingly. So trivalent impurity atom is what? Boron, aluminum, gallium and indium. Got it? So now come to the structure of that one again. So we are taking this time germanium semiconductor and indium as dopant. What is indium called here? Indium is what? Indium is called dopant. Try to understand, okay? Indium is called what? Dopant atom. Fine? Dopant atom. Fine? Okay. So as indium is having how many electrons in their outermost shell? Indium is having 3 electrons in their outermost cell. So, and vacancy is for how much? How many electrons? Vacancy is for how many electrons? Vacancy is for 4 electrons. But here we have only 3 electrons. Electron number 1, electron number 2 and electron number 3. Electron number 1, electron number 2 and electron number 3. But vacancy is for 4, and we are having only 3 electrons. So, suppose there are 4 seats, 4 chairs on which we can sit, fine. But if there are only 3 persons, so 3 chairs will be filled and 1 chair will be remain vacant. So that vacant chair will be termed as what? That vacant chair will be termed as a free space for electron, Got it? And that free space for electron is called holes. Understood? Holes, holes. Okay. So wherever there is vacancy of electron, there is a seat for electron, that is called hole. Fine. So in that way we can say that when we talk about p-type semiconductor or positive type semiconductor, in that number of holes are more than number of electrons. Number of holes is more than number of electrons. So in that way we can say that in p-type semiconductor, majority charge carriers, in p-type semiconductor, majority charge carrier is holes and minority charge carrier is what? Electrons. So you can see that here it is written here obviously. In p-type semiconductor, electrons are minority charge carriers and holes are majority charge carriers. And because holes are majority charge carriers, that's why it is called positive type semiconductor. And in n-type semiconductor, majority charge carrier is what? Electrons. That's why it is called n-type, negative type semiconductor. I hope you have got this point. Here we are having this difference between intrinsic and extrinsic semiconductor. This question also they have asked many times. When you see previous year question paper, you can see that they have asked many times what is the difference between intrinsic semiconductor and extrinsic semiconductor. Okay. Then they have also asked the difference between n-type and p-type semiconductor. So let's summarize difference between n-type and p-type semiconductor. N-type is negative type semiconductor, first difference. P-type is positive type semiconductor. N-type is having electron as minority charge carriers, holes as minority charge carriers. In p-type semiconductor, holes are majority charge carriers, electrons are minority charge carriers. Got it? To make n-type semiconductor, remember, to make n-type semiconductor we have to use pentavalent impurity atoms. To make p-type semiconductor we have to use trivalent impurity atoms. Got it? In n-type semiconductor there will be one extra electron, okay, for every impurity atom. But for p-type semiconductor there will be one vacancy, deficiency, okay, deficiency of electron. So in p-type semiconductor there is deficiency of electron, okay, and it can accept an electron. That's why sometimes p-type semiconductor is also called acceptor type. Please write down. Because later I'm in class, okay? But that key is my house, okay? Just wait here, okay? Be here. Wait here, no problem. Okay. See, because in p-type semiconductor, they can accept electrons. Why? Because they are having vacancy of electron. That's why sometimes p-type semiconductor also called acceptor type semiconductor. P-type semiconductor sometimes also called acceptor type semiconductor. And because in n-type semiconductor there is excess of electron. There is what? Excess of electron. That's why sometimes they also called donor type semiconductor. Understood? What is difference between p-type and n-type? Why it is called donor type, one is called acceptor type? I hope you have got this one. If any question you are having related to this topic, you can please write it down. Okay, anyone, if you are having any question till now, you can ask in the chat box, please. Okay, thank you so much. Anyone else? Okay, so should we move to next topic? Okay, we are moving to next topic. Okay. Now we have made p-type semiconductor and n-type semiconductor. Now we will discuss how we can make p-n junction diode. How we can make p-n junction diode, you know. Very simple. Okay. One, suppose we are having two wafers, two wafers of one of P type and other is of N type. Okay. And what we have to do if we connect, not like this exactly, but just I am telling you. So if you connect this one is P type, suppose this red is P type and this black one is N type. So if you keep like this, so there will be a junction, okay, between these two, and that is called, that's why that is called what? PN junction diode. PN junction diode. Junction is what? Junction is a point where two things meeting, junction is a point where two things, two substance, two materials are meeting. That is called what? Junction. There are railway junctions too, where train are coming and going. Okay, many trains are coming together. Many trains are coming to the same station, and then from that station going in different directions. Okay, so that's why that point is called junction. Got it? So when we attach p-type semiconductor and n-type semiconductor, it is forming a p-n junction. Okay. So how to form p-n junction? To make p-n junction, n-type and p-type silicon crystals are cut into thin wafers. If on a wafer of n-type silicon, an aluminum film is placed, and into silicon and p-type semiconductor is formed on n-type semiconductor. Such a formation of p region on n region is called p-n junction. Why this cannot be done? This can also be done, but problem will be that even if we are trying very hard, but still there will be some gap between n-type semiconductor and p-type semiconductor. So just attaching these two will not work. So what we have to do, we have to make p-type will happen. N-type semiconductor will connect it to each other. Type of semiconductor will be attached to each other. First process that will be going to happen is called diffusion. You can please write down. First thing that will be going to happen is called what? Diffusion. And in diffusion process, in diffusion process, it will be jumping towards p side. Got it? Electrons from n side will be jumping to what? P side. And holes from p side will be jumping to the n side. Yes or no? Are you getting my point? Are you getting my point, my dear students? So when we connect p-type semiconductor and n-type semiconductor together, so what will happen? Electrons, that means majority charge carriers from n type of semiconductor will be moving towards the p-type semiconductor. Okay, or you can say that electrons will be jumping from n-type semiconductor to p-type semiconductor. In the same way, holes from p-type semiconductor will be jumping towards which semiconductor? N-type semiconductor. So simply you can also say that in diffusion process, majority charge carriers will exchange their places. Got it? Majority charge carriers will be moving from one type of semiconductor to the others. And if you want to elaborate it, you can just write down that electrons from n side will be moving towards p side, and holes from p side will be moving towards the n side. Got it? And due to this moving of charge, one current will be produced, and that current is termed as diffusion current. That current is termed as what? Diffusion current. Okay. So my dear students, first thing that will be going to happen when p-type semiconductor is connected with n-type semiconductor is what? Diffusion process. In diffusion process, majority charge carriers will be exchanging their positions, like electrons from n side will be jumping to the p side, and holes from p side will be going towards the n side. Got it? And in that way, what we will have is called depletion region or depletion layer. Now question is that why it is called depletion layer? Very interesting one, you know. So suppose when it is just connected to each other, in these regions, you know, there are free electron, there are free holes. Yes or no? There are free holes. Here, in this region, there are free electrons. Why? Because we know that in n-type semiconductor, majority charge carriers will be what? Electrons. Majority charge carriers will be what? Electrons. So we can see that before diffusion process, in this region also there was majority charge carriers electrons are here, and in this region there were holes here. Okay, in this region. Why? Because we know that in case of p-type semiconductors, holes will be more. Got it? But as soon as diffusion process started, okay, electrons jumped from here to here, and holes jumped from here to here. Got it? And as earlier we have discussed that holes means what? Holes just means a vacancy of electron, a vacancy for electron. Okay? Understood? So what we can say is, here electrons moved from here to here and filling the holes. Got it? So now there is no any free electrons remains here, and the holes that was free earlier was filled by electron, making it a complete atom. Making it what? Complete atom. So in this way, in this region, near to the junction, please try to understand, due to the diffusion process, there will be no free charge. There will be no free charge around the junction, and there will be depletion. There will be what? Depletion. Depletion means what? Reduction. Another word that we can use for depletion is what? Another word that can be used for depletion is what? Deplete. Deplete means what? A reduction in something. A reduction means what? That means that free charge is reduced. Earlier free charge will in very high number, now free charge is in very less number. That's why there will be a region, that region will be termed as what? Depletion region or depletion layer. Okay, so depletion layer will be formed because of the diffusion process. Got it? Now one more thing is that earlier p-type semiconductor, you know, even though p-type is having holes as majority charge carriers, but still if you talk about net charge of p side, it will be neutral. And if you talk about net charge of n type, it again will be neutral. But after diffusion process, we have seen that electrons are jumping from n to p, got it? And holes are jumping from p to n, so making this side positive, and this side negative. And due to this one, we are having one electric field will be created. Which is in the direction of positive to negative. We know that direction of electric field is always from what? Positive to negative. So this electric field, induced electric field, will prevent further diffusion of majority charge carriers. Got it? That means when p-type and n-type semiconductor are connected together, it will form a p-n junction, and first process that will be started will be called diffusion process, and current that will be formed in that diffusion process will be termed as diffusion current. Understood? After that diffusion current, there we will have one induced electric field, and that induced electric field will prevent further diffusion of majority charge carriers from P to N and N to P. Got it? If any electrons, if any electron now try to jump from N to P, okay, it should have a large amount of energy. It should have a large amount of energy because there is a potential barrier, you know. That's why it is called what? Potential barrier. Why? Because if any electron is trying to jump from here to here, that electron will need a significant amount of energy to jump from N to P now. Got it? And I will tell you how they will get energy later. But earlier they can easily jumping from here to here. They can easily jumping from here to here. But now it is difficult for them. It is now difficult for them to jump easily. It is difficult for them to jump easily now from N type to P type. That's why we called it as potential barrier. Barrier means what? Barrier means something that is stopping something to happen. Yes or no? That's why it is called what? Potential barrier. Got it? And potential is something which is related to energy. Understood? Like you are running and suddenly there comes a wall in front of you. So you have to put high energy, extra energy to jump that wall. So this potential barrier is just like that wall for what? For whom? For electrons. Got it? That's why this barrier is called as potential barrier. Okay? But one thing that we have to understand once more, that first process will field, induce electric field, but you know that electric field will prevent majority charge carriers only. Majority charge carriers only. After that electric field, no electrons will be jumping from N to P and no holes will be jumping from P to N. Got it? But one thing can do that. And what is that? That is called majority charge carriers. We know that in case of p-type semiconductor, electrons are minority charge carriers, and in case of n-type semiconductor, holes are minority charge carriers. And we also know that electric field try to move positive charge in their own direction. Please try to understand. You know, this is holes, this is hole, you know, and this is electric field having this direction. So you know already that electric field always try to move a positive charge in their own direction. So they can move it to here, and they will try to push negative charge in opposite to their direction. So because electron is here, so electron can move from here to here with the help of this electric field. Electron can move from P to N with the help of this electric field, and this hole can move from here to here with the help of this electric field. So this process after diffusion is called drift process. It's called what? Drift process. So in diffusion, my dear students, in diffusion, majority charge carriers will exchanging the places. Okay, but in case of drift process, in diffusion, majority charge carriers are exchanging their positions. But in case of drift process, minority charge carriers will exchange their positions. So after that, what we can have is that after the process of diffusion and drift, you know, and when their speed will become equal, they will be set as in equilibrium. And when the process of diffusion will become equal to process of diffusion, okay, they will set to be in the equilibrium position, and then we will receive our PN junction diode, and then we will receive our PN junction diode. Got it? So when we will receive our PN junction diode, we can bias it, biasing. That is called what? Biasing. Okay, that means you are having something, and how you want to use that. Suppose if you are having something, you are having rice. Okay, so using rice, you can make khichdi, you can make jeera rice, you can make pulao, you can make kheer, you can make many things using rice. Okay, there are different ways of preparing, cooking, and utilizing your rice. Understood? In the same way, when we have our PN junction, in the same way, when we are having our PN junction, PN junction can be used in two ways. Got it? And those ways are called biasing. Biasing is nothing but just two type of ways using which we can use our PN junction, and that too is very much simple. Okay, one is called forward biasing and other is called what? Reverse biasing. One will be called what? Forward biasing, and other will be called what? Reverse biasing. Got it? In forward biasing it's very simple. In forward biasing, you can, in forward biasing, it is very much simple that in forward biasing, P type semiconductor is connected to positive and N type semiconductor connected to negative. You can just write it down, very important thing. Okay, in forward biasing, what we are talking about? We are talking about forward biasing. If you have any question, you can ask me. If you are having any question, you can ask me. Okay. So we are using forward bias. Okay, so in forward biasing, in forward biasing we connect positive terminal of the battery. We connect positive terminal of the battery with P type semiconductor and and negative terminal of the battery with the N side of the PN junction. Got it? Now we know that in PN junction there are two kinds of semiconductor, P type and N type. In forward bias, we connect positive terminal to P side and negative terminal to what? N side. Okay. If you don't want to make this diagram in board exams, you can also use this symbol. You can also use what? This symbol. Got it? This will denote P side and this will denote N side. Got it? So you can see that P side is connected with positive terminal and N side is connected with what? Negative terminal. Understood? Now we will discuss one more thing about this forward bias. Okay. Yes, very good question. Thermal agitation we will discuss. Okay. So what will be the like benefits when we have connected PN junction in forward bias? Again, I am telling you, my dear students, biasing just means what? Biasing means the ways through which we can use our PN junction, through which we can connect our PN junction with the battery. It's very simple that when positive terminal of the battery will be connected to P side and negative terminal will be connected to N side, it is called forward bias. Got it? And in that forward bias, one thing will happen. See, this is positive and your holes are positive, your holes are positive. So what will it do? It will just push these holes towards the junction. Please try to understand. This is positive, your holes are positive. So positive and positive will repel each other. So in forward bias, holes are just going towards the junction. In the same way, this is negative terminal and you are having negative charge as majority charge carriers. So this will push these negative charge carriers towards the junction again, making your potential barrier thinner, making your potential barrier less. Got it? Making your potential barrier less. In this way, it will help to conduct electricity. In this way, it can help conduct electricity. So what we can conclude from this is that in forward biasing, PN junction will behave as, in forward biasing, PN junction will behave as an In forward biasing, PN junction will behave as a conductor. Yes, you can ask your question, please. You can ask your potential barrier is something that try to resist electrons from moving from n side to p side, and it is created by the diffusion process. It is created by the diffusion process. Got it? Potential barrier is something that is making a barrier for electrons to exchange from p side to n side. And how it is created? It is created by the diffusion process. We will have an external electric field, or like induced electric field, which will resist electrons to move from n side to p side. If electrons trying to move if electrons are trying to move from n side to p side, they must have some energy. They must have some energy, and that energy we are trying to provide in forward bias. You can see that. Okay. So in forward bias, they can ask you question: what will happen to potential barrier in forward bias? They can ask you question like that: what is the potential barrier? How potential barrier will change in forward bias? So what you have to write? In forward biasing, potential barrier will reduce. You can see that earlier potential barrier was this one, but in forward bias it is reduced to this one. Got it? So this is our forward bias. Okay, I hope you understood this one. Then we come to reverse bias. It's very simple. It is just opposite of what? Forward bias. In reverse bias, we will connect negative to the P side and positive to N side. Got it? And in this way, you can see that holes will be going away from the junction. Holes will be going away from the junction, and here electrons again going away from the junction. So in this way, potential barrier will be broadened. In this case, in case of reverse bias, potential barrier will be broadened and making electrons impossible to jump. Making electrons impossible to jump. You can see that earlier potential barrier was this one, and when we are using reverse bias, it was increased. It was increased to this one, making electrons almost impossible to jump, okay, from n side to p side and all. Okay, so making semiconductor, p-n junction diode and insulator. So please write down: in forward bias, semiconductor behaves as a in forward bias, p-n junction diode behaves as a conductor. In forward bias, p-n junction behaves as a conductor, and in reverse bias, p-n junction behaves as an insulator. Got it? In forward bias, p-n junction will behave as a conductor, and in reverse bias, p-n junction will behave as an insulator. Please try to understand. This question can be asked in your board examination. Okay, so try to understand, and if you are having any question, you can ask me. Yes, you can ask your question. JNB West Siang, please, you can ask your question. JNB West Siang, you can ask your question. Hello, are you there? You can type your question, or you can switch on your microphone. Okay. Should we move to next topic? Now, we have discussed about p-type, n-type. We have discussed about how to make p-type, n-type. We have discussed about the p-n junction. What is the diffusion process? What is the drift process? Got it? And how we can use p-n junction in forward bias and reverse bias. Okay. Now we will draw a graph. We will draw a graph for forward bias and reverse bias. So when we draw graph for forward bias, it is called forward characteristics. When we draw a graph for forward bias, it is called forward characteristics, in which you can see that initially there is very less current or no current. Initially you can see that there is very less current or no current. Got it? Because this voltage is used to used to making potential barrier lesser. At this point your potential barrier will become nil. At this point your potential barrier will become nil, will become zero, and after this point electron can move very easily. Electron can move very easily, making a high current. Making what? A high current. That's why, my dear students, this voltage is called threshold voltage. What is that? Threshold voltage. So till threshold voltage, okay, voltage is used to make potential barrier thinner. And after, at this point your potential barrier will become zero, and after this point your p-n junction will behave as a conductor, a very good conductor, and you will receive the current. Remember, in forward bias your current will be in milliampere. Remember that thing is very important in forward bias, because we are having practical also from this topic. So in forward bias the current will be in milliampere. Got it? And this graph will be called characteristics graph. Okay, so if in board exam they will ask you that what are the forward characteristics of p-n junction diode, so you have to draw this diagram. Got it? Yes. And please try to understand about threshold voltage. Okay, threshold voltage is that voltage which is till which it is used for like decreasing the potential barrier. And after threshold voltage our p-n junction diode will behave as a conductor. Next one is what? Reverse characteristics. Okay, in reverse characteristics you can see that our n side, our n side is connected to what? -1. And our p side is connected to what? Our p side is connected to negative terminal, and n side is connected to what? Positive terminal. And one more thing that you have to understand is what? In reverse bias current that we are getting is in microampere, and you know that micro is very much smaller than milli. So please try to understand that in forward bias our p-n junction will behave as a conductor, and in reverse bias our p-n junction will behave as a insulator. And the type of graph that we are getting is like this. Okay, here you can see that when we are increasing negative potential, why I am writing negative? Because if in first time I have used positive there, and in second time if I am using negative there, I have to change the setup just opposite. Okay, so if I am using first quadrant in first forward bias, I have to use what? Third quadrant in the reverse bias. So I am giving negative potential, and due to that, because of that, potential barrier will be widened. And but at one time there will be a time when we are using that much force due to the voltage, from which atoms will be breakdown. And after breaking down of atom we can receive a very high amount of electron, and that high amount of electron will give us very large amount of electric current. Okay, that's why this point is called breakdown voltage. This point is called what, my distance? Breakdown voltage. Why? Because at this potential, at this voltage, atoms are started breaking down, and from that atoms we will receive electrons in very large number, and that electrons will produce a very high current. Got it? So my dear students, till breakdown voltage in reverse bias, p-n junction diode will behave as a insulator. Okay, now last topic of this chapter, okay, is what? Use of that p-n junction. My dear students. Okay, in earlier, like in previous years, in your syllabus there are many uses of PN junction diode, like as a rectifier, as LED, as a photodiode, as a solar cell, you know. But now your syllabus get reduced and only one use is there, and that use is called rectifier. I will just take your 5 minutes, 5 to 10 minutes. Please be with me. Okay. So rectifier is a device which used to convert. You know, we have discussed about AC current and DC current. You know, chapter number 7. Okay, okay, okay. Thermal agitation means, you know, thermal agitation means we can agitate electrons by using thermal means, by giving heat energy, by giving what? Heat energy. Got it? So when any electrons is jumping from lower orbit to higher orbit, okay, by giving just heat energy, by giving what? Just heat energy. And heat is also called thermal, you know. Heat energy is also called what? Thermal energy. So agitation of electrons just by giving them heat energy, and it is jumping from a lower orbit to a higher orbit, will be called thermal agitation. Okay, Jamie Baksa. Okay, so just give me 5 to 10 minutes. Okay, this is important one. Thank you so much. Okay, so you know, rectifier is what? Rectifier is a device that converts alternating current into direct current. Alternating current into what? Direct current. In our daily life, we are using many devices in which, you know, they have already installed. They have already installed a rectifier inside it, because generally we are getting alternating current from the power source. Our government, you know, our government provide us alternating current. But in our home, in our offices, in our school, there are devices which run on direct current. As because I am using mobile phone, I am using laptop, they all run on direct current, you know, operate on direct current. So there is a device called rectifier that we have to use, that convert. Please try to understand what is rectifier. A rectifier is a device that converts alternating current into direct current. Got it? And to make that rectifier, we use PN junction diode. So there are two kinds of rectifier. One is half wave rectifier and other is what? Full wave rectifier. Got it? So this is just by distance. Uh, just try to see this diagram. In half wave rectifier, we are using one diode. In half wave rectifier, we are using how many diode? One diode. This you have to remember. This is your input. You can see that in your input, we are giving alternating current. In your input, we are giving what? Alternating current. This is sign of what? Alternating current. And what is the sign of direct current? If it is direct current, we simply write 5 volt, 6 volt, 10 volt, 1.5 volt and all. Got it? So this is your alternating current, and it will produce you what? Direct current using the help of a PN junction diode. So just try to understand. In first positive half cycle, please, in first positive half cycle, this diode will be forward bias. In first positive half cycle, this diode will be what? In forward bias. Got it? Remember, in first positive half cycle, this diode here it will be positive, and here it will be what? Negative. You can see that here it will be positive in first positive half cycle, and here it will be negative. So when your P side will be positive and N side will be negative, this kind of situation will be called forward bias. And in forward bias, our diode will behave as a conductor, and it will conduct electricity, and it will provide us the waveform. It will provide us the waveform. But in second half cycle, that is negative one. That is what? Negative one. So in that case, it will become negative side, and this will become what? Positive side. Got it? So in this case, it will be in reverse bias, and because it is in reverse bias, it will behave as an insulator. It is behave as an what? Insulator. And you know that insulator cannot conduct electricity. Insulator cannot conduct electricity. Okay, so we will not able to receive any waveform. We will not able to receive any waveform. Got it? Then again, third positive half cycle. Then again what? Third positive half cycle, it will again in forward bias and we will receive our waveform. Okay. So why it is called half waveform, half wave rectifier? See, 1, 2, 3 and 4. We have given 4 waveforms, but we have received only 2 waveforms. Okay, so it is making half only. That's why we are calling it as half wave rectifier. That's why we are calling it as what? Half wave rectifier. Are you getting it? This is very important. Please try to understand. Okay, if yes, you can tell me yes. Okay, and if no, you can ask me question. Okay, so now last topic of this chapter is what? Full wave rectifier. So just very much simple concept is that in full wave rectifier, we will use 2 diodes. In full wave rectifier, how much diode we are going to use? One is D1, other is what? D2. Okay, and this type of arrangement is called center tapped full wave rectifier. Center tapped full wave rectifier. Okay, you can see that in first case, which diode is in forward bias? Tell me, in first cycle which diode is in forward bias? Anyone, can you see the diagram and tell me? In first positive half cycle, please tell me, so that I can know that you are able to see that this diagram. In first half cycle, which diode is in forward bias? Tell me. Do it fast. Write in chat box. Try to see this diagram very carefully and tell me, in first positive half cycle, which diode is in forward bias? Which diode is in forward bias? Diode number 1. Here, diode number 1 is in forward bias and diode number 2 is in reverse bias. So in this case, this will conduct electricity and this will not going to conduct any electricity. But in second negative half cycle, this will be in reverse bias and this will be in what? Forward bias. So this will conduct electricity and this will not conduct electricity. This will not conduct electricity. But every time, in every half cycle, we are receiving our output waveform. Okay, we are receiving our output waveform and you can see 1, 2, 3 and 4. We have given 4 input waveform, we have received 4 output waveform. That's why it is giving full out of full. That's why this kind of rectifier is called full wave rectifier. This kind of rectifier is called what? Full wave rectifier. Okay, so I hope, my dear students, you are able to understand something about semiconductor devices, and I want to tell you all the best for your board examination. Thank you so much. Bye bye. And if anyone asks you, want to ask me some questions, you can. Any GNV students, if you want to discuss something with me, you can discuss it, no problem. And from this chapter, a rectifier is very much important, and forward bias and reverse bias is very much important. Okay, so please try to draw those diagrams and that graph. Okay, so if you are not want to ask me any question, should we leave this class? Thank you so much. Bye bye. Thank you so much, JNV Golpara. Bye bye. Thank you so much, JNV Kachar. And I wish you all the best, all the dear students, for your board examination. Okay, and be positive in life. Okay, always. Thank you so much. Bye bye.